November 11, paper 21, number 8. Student learning an electric circuit connecting up the circuit. The student has already made one mistake with his connection. What is his mistake? As you can see, the mistake is that the battery, the negative part of the battery should be connected to the negative part of the ammeter, not the positive part. So this is wrong. Should be connected the negative to the negative. So what we shall say at this point is that we should reverse the connection between the ammeter and the battery. In the symbol below, draw in the space below, draw a circuit diagram using standard symbols. What we will do now is that we will start with the battery. Here is the battery, here is the positive part, here is the negative part, and then let's move on. We will have here our variable resistor. As you can see, the positive part is connected to the variable resistor. Here, positive part connected to the variable resistor, and then the other end of the variable resistor is connected to a coil. Here, the other end of the variable resistor is connected to the coil, and the other end of the coil is connected to the ammeter, and the ammeter is connected again to the battery, or to the battery that we have. Okay, that's for the first part regarding the diagram. The student now connects a voltmeter in the circuit, so the reading can be taken to find the resistance of the wire. The draw a voltmeter connected to the measure the potential difference across the coil. So in order to get the potential difference across this coil, we should do what? We should connect the voltmeter parallel to the coil. So they are now sharing the same starting point with the same ending point. So that's how we will draw the voltmeter. Having obtained a correctly working circuit, the reading of the 2-meter setting, the variables are as shown. Record the two values of the two readings. Here it will be 2.2, 2.4, 2.6, 2.8. So the value will be a 2.8. For the voltmeter reading, as you can see, here is a 10, 11, 12, 13, 14, 15. So here the value will be 11, 12. So it will be a 12 volt. Now we'll start from here. We have the trick part. The slider on the variable resistor, figure 8.2, is moved a small distance to the left, reducing the resistance. Type. State what happened to the reading on the 2 meters. First of all, reducing the resistance using Ohm's law. R is equal to V over I. So the resistance decreased. It means that the current will increase. So here we said that the ammeter reading will increase. They are all connected in series. So the resistance decrease means that the total resistance will decrease, and so the current will increase. What about the voltmeter? Let's see. First, we could say that if we have, for example, if we have here, it's a 20 volt. For example, this is a 20 volt as an EMF. And this coil, we already know that the potential difference across it was 12 volt. So the potential difference across this variable resistor will be what? Will be the remaining. So as you can see, in order to get the EMF or the voltage of the battery is divided between the variable resistor and the coil, or between the two resistors that we have. So here the 8 plus the 12 will be equal to 20. So again, what will happen when the resistance across the variable resistor will decrease? It means what? It means that the voltage, there is a relation between the resistance and the voltage. When the resistance across the variable resistor decreases, the voltage across it also will decrease. So here, instead of having an 8 volt, it will be a 6 volt, for example. So what will happen to the potential difference across this coil, the 6 volts? So the remaining here will not be a 12. Here, it will increase. Instead of being a 12 volt, it will be a 14 volts. So the potential difference across the coil will increase, while the potential difference across the variable resistor will decrease. But here he is asking about the voltmeter reading, and the voltmeter is already connected to the wire. So we could say that the value here of the voltmeter will also increase. This is for the first part. Let's remove all this explanation in order to enter the second question. The slider is adjusted so that the total resistance in the circuit is doubled, which gave the reading in figure 8.2. Calculate the new values of the reading on the meter. Right. First of all, he said that the reading is doubled, so the resistance increased by 2. So the current will decrease by 2 as well, which means that the current will be multiplied by half. Okay, so that's the idea here. So as you can see here, we have the ammeter in 2.8 ampere. So the ammeter here will be a 1.4 ampere. That's for the first part. The voltmeter reading. What will be the voltmeter reading? In order to answer this question, there is a lot of ways we could solve this question with, but we will solve it with using simple way of getting the resistance of this coil. Let's get the resistance of this coil using what? Using the information that we already have. When the current was at 2.8, the voltage was 12 across this coil. So we will use Ohm's law to get the resistance of this coil. The voltage was 12 and the current was at 2.8. So the resistance of the coil is 4.2857 ohms. Which means what? Which means that I could here write RC and a 4.2857. Okay. So that's the resistance of the coil, and the resistance is fixed, doesn't change. Right. Here he said that he doubled what? He doubled the resistance. What will be the voltage? Let's have here V is equal to IR. Okay. V is equal to IR. We already know the current. We already said here that the current will be a 1.4. The current here will be a 1.4 ampere. So here at this point, we could use this piece of information that the current will be a 1.4. And what's the resistance of the coil? Here we are talking about the coil. So the resistance of the coil, we already stated that it's a 4.2857. So what will be the voltage across this coil now? When the resistance now is 1.4, what will be the voltage? After calculating this, the voltage will be a 6 volt. So here we will write that the value of the voltmeter reading now across the coil will be a 6 volt. And that's it for this.